Well, let's start. Hello, everybody. Good morning, good afternoon, or good evening to everyone joining us from around the world. My name is Thiago Arantes. I work at IBGE, Brazilian Institute of Geography and Statistics. This is the Brazil National Statistics Office. And I have the pleasure of being a member also the UN Committee of Experts on Big Data for Official Statistics, the mobile phone data task team, and also be a member of the United Nations regional hub for big data in Brazil. It's a great pleasure to welcome today's webinar, ITU Jupyter Notebooks, a practical tool for analyzing mobile phone data for measuring the information society. So today's event is organized by UN Regional Hub in Brazil and brings together experts from the International Telecommunication Union, the ITU, and the objective is to present tools that support the use of mobile phone data for producing of official ICT statistics, information and communication, telecommunication statistics for and also SDG, the Sustainable Development Goals indicators. Before we begin, I would like to remind everyone that this session is being recorded. Please also feel free to submit your questions at any time using the chat. We will collect these questions throughout the presentation and address as many as possible during the Q&A session after the presentations. And since we are delighted to have participants join us from many different countries, please let us know where you are connecting from and writing your country in the chat. So I will introduce the speakers today. We are honored to welcome here two fellow colleagues of me in the mobile phone data task team. They are experts of the International Telecommunication Union. Our first speaker is Mrs. Esperança Magpantai. She's a senior statistician in the ICT Data and Analytics Division at the ITU. She leads the mobile phone data desk team at the UN and has extensive experience in developing international standards and methodologies for ICT statistics and the use of mobile phone data in official statistics. Joining her is Mr. Frederick Eriksson. He's a data scientist at the ITU's ICT Data and Analytics Division also, with nearly 2 decades of experience in statistics, data science, and quantitative analysis across international organizations and the private sector. Frederick has played a key role in ITU, working on mobile phone data and big data applications for official statistics. Today's presentation, we will introduce the ITU series of Jupyter Notebooks, developing PySpark, and which provide practical guidance for processing mobile phone data from the raw CDR, the call detail records, to quality assurance procedures and to home detections, algorithms, and calculations of SDG indicators, especially the 17.8.1 indicator, which is the percentage of individuals using the internet. The presentation will also showcase experience from pilot implementations and discuss how these tools can help countries strengthen their ICT statistics systems. Esperança and Frederick, thank you very much for being with us today, and the floor is yours.
Thank you so much, Tiago. Good afternoon, good morning to you. We are happy to be here to share with you the work that we had accomplished with regards to the use of mobile phone data, particularly the tool that we will be focusing on today, to help those practitioners, national statistical offices, and also colleagues who may want to start using mobile phone data for their statistical work. So I just want to confirm that you can see my screen.
Yes, we can see.
Thank you so much. So I'll start my presentation. And so as Tiago mentioned, we will be focusing on the tool today, but there's a lot more work around mobile phone data that we can provide more information in other occasion. But today, this is about the ITU Jupyter Notebook. And I will give you first some introduction on what is mobile phone data, what are the use cases that could be or application that we are looking at with regards to this new data source, and what is the typical processes that are involved with regards to analyzing this data. So we at the ITU, just to give you some background to our work, we are coming from the statistics division of the ITU, and our main work is basically to collect and disseminate the data that pertains to our sector, which is the telecommunication or ICT. And this relates to information that are both from the supply side, so data that are coming from regulatory agencies and ministries, and the demand side data, so data that are collected by national statistical offices. So on the supply side data, they are data on the number of subscriptions, telecom revenue and investment, prices. So those are the example of data that we collect and disseminate. And on the demand side data is particularly related to, for example, how many people are using the internet, which is an indicator that we will be focusing on today. And there are also other indicators that are related to the use of, for example, mobile phone, or whether a household is connected or not to the internet. And all these data are available in our dissemination. So we have a data hub. The data hub is where we disseminate all this information at the country level and also some aggregates. But the third area of our work is really on the use of big data. So mobile phone data is just one of them. And our objective is to be able to complement or supplement the traditional data collection that we have from regulators, ministries, and national statistical offices. And we have been doing this work since 2014 when we started conceptualizing on how we can use big data to measure the information society. And we later look at how this work can be done by developing methodologies. And again, like what I mentioned, the idea here is to see how we can complement traditional indicators and at the same time to see new indicators that we can calculate from big data. And specifically for mobile phone data, one of the benefits of using this is on providing more granular data with regards to the geography. And as you know, mobile phone data is generated regularly whenever we use our mobile phone. And so the timeliness of data that this new data source can provide is one of the benefits that we know. And of course, we also want to see how, for example, countries that do not have information for specific indicators, how we can use it as an alternative source for these countries. With regards to information society indicator, which is, of course, the focus of our presentation today, we had done several pilots. And based on these pilots, we developed the methodology. So in 2016 and to 2018, we piloted in 5 countries. From the Latin American region, we had Colombia at that time. And in that pilot, we look at 16 ICT indicators, mainly on subscriptions, coverage, and those information that we traditionally collect from regulators and ministries. But in 2020 to 2021, we look at 2 more pilots. One is in Brazil and one is in Indonesia. And this is where we look at the 2 SDG indicators. One of them is the focus of our presentation today, which is on the percentage of population using the internet. There's also an ongoing work. So we continue this work together with other partners. The one particular partnership that we have is with the World Bank, where we have a project implementing in 25 countries. And the objective here is to implement it and make mobile phone data a source for official statistics. And so this work is currently ongoing. There are a number of countries also in Latin America region, including Peru, Argentina, and Brazil that are part of the cohort. And also we have projects in ITU, so we're doing it separately in some of the countries that you can see from the screen. And so all these discussions are currently ongoing. So now moving to the subject matter itself. So the mobile phone data. So if you're not familiar with this new data source, I will try to give you some introduction as to what is mobile phone data and how we can analyze it. So what we mean by mobile phone data, there's a lot of mobile phone data that are generated. It can be an active signaling. So active signaling is when your mobile phone connects to the mobile towers. And so this is regularly captured by the operators. Or the passive signaling, where, for example, even if you're not using your phone, you are the activities on the phone is being tracked with regards to whether they are connecting to the network. And there's of course the mobile money and also other information that regards to the customer data. But what we are really after is the call data records. And this is the data that we use in the Jupyter Notebooks that we will be presenting to you. There's also GPS data, but this is not the data that are normally collected by mobile network operators. So how is the CDR data generated? So as mentioned, the CDR data, these are data that are collected by mobile network operators whenever you make a call, send an SMS, or use data when you browse the internet from your mobile phone. What I want to emphasize here, because this is always a question that we get, is about what type of data that that we get from operators. So the data is not the actual position of the mobile device, so it's not the actual position of the person, but it is the observed location or position of the mobile tower where the person or your device connects to. So this is, I think, a distinction that you have to keep in mind when analyzing CDR data. And so this is routinely stored by mobile network operators for billing purposes. And just to illustrate the concept of the device location as the observed location, as the cell tower location. So if you are a subscriber, for example, leaving your place, you're connected to cell tower A, while you move, so the device connects to cell tower B or cell tower C. So during the day, and you can see the time of the day, your connection or the location of your mobile device is shown by the cell tower location as you move from one tower to another. And this is the type of data that we will be analyzing. Tiago mentioned about the UN Big Data Group, particularly the one on the task team on mobile phone data. So mobile phone data can be used in 6 different areas. It can be into RESEM, migration, dynamic population, disaster or displacement, transport and commuting, and the information society. So today we are focusing on the information society. But once you have access to this data, you will be able to work on all these applications. And we have a number of guides or methodology that are available in the Big Data Task Team website, and the link that I provided in the screen is where you can get them, and I invite you to browse them after this webinar. So why do we look at the use of mobile phone data for internet use data? So you can see from the map, the data that we look at is from 2019 until 2024. I think there's one country for 2025, and this shows you the availability of internet use data. So individuals using the internet. And as you can see from the screen, there are a number of countries where data are very old, or they have not even collected data for this particular indicator. There are some countries that collect this data regularly, mainly the countries in Europe, some in Asia, and in Latin America. But there's still a lot of countries that do not collect this data. So there's a huge gap that still exists with regards to this particular indicator. And as Tiago mentioned, this is an SDG indicator. So all countries of the world has to be producing this indicator to be able to track their progress with regards to reaching the SDGs. And the SDG that it refers to is in Goal 17, which it has a target to enhance the use of enabling technology. And the particular indicator is indicator 1781, which is the proportion of individuals using the internet. So the map that I showed you is specifically for this indicator. So what is indicators SDG 1781 if we look at the use of mobile phone data? So this is basically, as I mentioned, these are data that are based on mobile phone events. So whenever a subscription or a person use the mobile phone, it connects to a network, to a tower. And so all the activities that relates to the events that are captured by the mobile operators are the ones that we will be analyzing. So these are basically subscriptions that are generating data, traffic or events, whether it's in 3G or 4G and above, as well as those that are connecting to 2G networks. So for the definition of a mobile broadband or internet connection, we use everything that is above or equal or above 3G networks. And what we hope to achieve here is that we are able to disaggregate them by technology, also by the local administrative unit. So you can see areas of the country that are connected or not, and also to see what is the dominant or the highest technology to identify as the internet use technology. And so out of these processes, we will be able to analyze the data and come up at an aggregated data for this particular indicator. And we will be showing all these steps to you later on. There's a specific step that needs to be done, of course. We need to have access to the data. Operators' data are sensitive data with regards to privacy. And so there are access models that are available that can be explored by countries. It can be operator-led, meaning the operators are the one analyzing the data, and then only the results are being transferred to national statistical offices or regulators or ministries. It can be a second model where the operators provide the raw data to the regulators, ministries, and then it's the agencies who, or the National Statistics Office, who aggregate this data and come up with the indicator. And there's a third access model where a third party is provided as an access to analyze the data from the MNO or the operator premises. And they are the aggregator of this data who provides the data to the National Statistics Office. So what are the requirements to analyze the mobile phone data? And this will be showing you when Frederick starts the presentation on the notebooks. So we assume that there's mobile phone data or synthetic data if you don't have access to the data yet. And these data are important, of course, to gain experience as to the analysis of the data. You also need to have the hardware, the necessary hardware, can be cloud or on premise. It can be also infrastructure that is in the mobile operators. You also need software tools that you will be using. So for this case, the Jupyter Notebooks will be very useful for you when you start analyzing mobile phone data. And of course, you need some skills. It does not need to be a one single person. It can be a group of people that works together to do data analysis, data management, programming, making sense of the statistics or the outputs. And of course, you need someone who knows the domain, who can make sense of the outputs and the results that you come up from the mobile phone data. So these are the requirements if you want to analyze mobile phone data. Um, in addition to the MNO data, in addition to the mobile phone data, you will need other reference data. And these data are usually collected or available in national statistical offices, but there's also additional data that could be taken from other sources, such as the world population data. You need to have also the boundaries, so the geographic boundaries, so that you can map the results, and also when doing the home location. There's the cell location data that you will need, and this is usually available from the regulator or the operators. You also need household surveys data and some microdata to be able to further analyze it or do cross-validation of your MPD results. And all of these data can be, of course, collected or requested from the different agencies who will be working together in the analysis of this data. So this is my last slide. And so the last, the steps in analyzing MPD, as I mentioned, it's important that you have the data. So you need to acquire it. You need to process the data. You need to see the quality of the data that you receive. There needs to be a home detection, and then other steps that you need to perform after the calculation. And so all of this we will be showing you in the next presentations. So this is a methodological guide. I invite you to look at this afterwards. This is the link that I provided in the previous slide. Over to you, Frederick.
Thank you, Esperanza, and I hope you can get a glass of water. I hope everything's fine. Thank you so much for the presentation. Good morning, everyone, or good afternoon. Now we will be diving into the notebooks a bit more. I will just try to show the screen here as well. See if you can see it. If this works, if anyone can also just tell me thumbs up. Perfect. Excellent. So much. Thank you. So again, Esperanza mentioned the purpose and the requirement. What are for these Jupyter notebooks? Just to mention it again, that it's really sort of a practical introduction to working with the mobile phone data, going through the workflow that Esperanza was just showing. It's sort of the series. There's multiple different notebooks that are going from each step, from A to Z, and all of them includes the code and documentation that is required, actually, and what you might be interested in on what happens in each step. Today we will, the environment and staff that Esperanza already mentioned to run these. It's the notebooks are written in Python or PySpark as well. They're also available free on GitHub in the GitHub repository. There's the link there, direct link below, but there's also a link to the ITU website on big data and mobile phone data, where you can also find many other resources as well. I can just mention that we are doing some updates to the GitHub repository, and in a few weeks there will be an update with newer notebooks. I also just want to mention the ITU Jupyter Notebook immersion days that we sometimes do, which is when we sit together with a smaller team and actually have a training session where we can go through the notebooks themselves and everyone gets to run them. You can change different parameters and actually also use different synthetic data, so we can actually go through them step by step. Now that takes a bit longer time, so we don't have time for that today. But this is also an option in case there's teams or people that wants to use that. So going into notebooks, the data structure that is working for the CDRs, what is required to run the notebooks? Well, there's minimum 7 fields. It's the subscriber identification, there's the timestamp of when the event was happened, there's the cell ID and the location of the cell tower, where it's located. There's also the data type, whether it's call detail, let's say call SMS, or if it's a data event. And then also what is the technology for the cell tower itself. So if it's a 3G, 4G, 5G, etc. Now, the notebooks also work if you have, coming from usually the CRM systems, the age and the gender of the subscriber. Now, this will allow you to do a lot more analysis on the demographics within each area as well. So the notebooks can work with this. This is not always, it's not required, but it's really nice to have possible. But even if you don't have access to phone data, real mobile phone data, you can actually start using the notebooks directly. We are also using synthetic data, which is the artificial data that sort of try to mimic these statistical patterns of the real mobile phone data. And this is something that we're working on very much to try to make it as realistic as possible. And synthetic mobile phone data generation, synthetic data is used a lot more now, even training the new large language models. It's been used also for a long time. And the approach that we're taking is really to use synthetic data for training purposes. So we're not necessarily generating 1 million subscribers, but we're generating tens of thousands, perhaps, subscribers too. So we can get a feeling for what working with mobile phone data is. We're also currently developing a new model that will be available as well, where you can set different parameters and create your own synthetic data. So very quickly on how that synthetic data works, it's that we're looking at creating a base layer. So you can either upload your own mobile cell tower locations, or you can also use open source for this. We're looking at the population that lives around these cell towers, and then use that as sort of a weighting factor when generating the mobile phone data events. And this is to make it a lot more realistic, so that the events, mobile phone data events, do not necessarily happen in areas where people don't live. There's also going to be a lot of different parameters setting on different type of user types, movement types, how many events that you can assume that people can do, how many times they use their phone, how they're moving from one place to another, whether they're active at night or normally sleep at night, and so on as well. So there's a lot of different parameters that can be set in this new synthetic data generator. And for example, it can generate quite a lot of records. So 3,000 subscribers for 1 month, it can easily be 500,000 records, for example. And this is quite low usage as well. So looking here is just some synthetic data, completely not showing all the, not showing any specific user type, but just showing it for an area of Rwanda using real cell locations for Rwanda. And as I said, you see that most of the cell towers are located in Kigali or in the central and the towns, which means that most of the events are then happening there as well. One question that I just want to mention that we quite often get is on the privacy of the data itself. So one thing that we have in the notebooks that it's not necessarily part of the standard workflow on the notebooks itself, but we get a lot of questions on the pseudonymization of personal data. So we added another notebooks just for test that shows different type of examples of hashing functions for the privacy protection that can be used in terms of transforming some real subscriber data into sort of hashed or and pseudonymized data, for example. This is very important, obviously, if you're going to share any of the data in the future, to not share the real actual data. Now, going into processing and some sanity checks and filtering of the data itself, the first step that we need to do is actually checking the raw files. And this is a specific notebook that is only for this purpose. Now, hopefully, the mobile phone data operators will give you very clean files if you get the access to the real CDR data. But there's obviously not necessarily sure that that will happen. So it's very important to check these. For example, the notebooks here can identify hidden characters. We can look at duplicated rows, whether there's missing delimiters in the file itself, which means that the file will not be able to load properly into the notebooks. There could be inconsistency in data types. We made some improvements to use different type of data types for specifically datetime formats that can be very different across different regions. But still, there could be some that fall through the cracks. It can also be some impossible timestamps. For example, here, the 55th hour of the day, which I do not believe exist. Now, what this notebook does is that it actually creates an error file and showcases exactly which row, which is the issue, and this is available once you run this notebook. The next step, again, once the data set has been loaded in one of the first notebooks, is to once again just make sure that you don't have any duplicated rows. Now, hopefully this has been done before and these have been removed and checked, but just in case, this is another step that we will do. In addition, there's different types of filtering of the data in the beginning that in some cases, for some use cases, is definitely needed. In other use cases, it may not necessarily be needed. But this one is something that can happen. We've seen it in previous studies as well, that the mobile phone operator might do some network tests at quite often a specific hour of the day or specific days, where you can end up with large number of records for a specific subscriber and so quite often also for a specific cell tower. So you can set the parameter of what is the maximum number of events in a day that sort of a human normally can do. For example, 200-300 is what we've used, and then identify and then filter out the ones that go above that, those subscribers. So here we can see a normal subscriber might have, let's say, different types of records. This person had 25 records at cell A, 18 number of records in cell B, and so on as well. This is typical behavior. Now, a robot-like subscriber could have, in this case, 287 records in one cell tower in a single day. Now, this is really something that could distort the figures at the end. Another filter that we can do is, for some use cases, might be not interested in keeping all different events. For example, if we're looking at the home load detection, we have a long time series, then some of these random events could, by removing them, they can actually reduce the size of the file, and it can make it processing faster as well. So the random events is where the subscriber was only connected to a cell tower once in the entire period. So for example, the subscriber A in this example was connected to the cell tower 12 times and cell tower B 7 times and so on, but was only there in cell C and cell D once. So this is likely not going to be the home of this subscriber. So by removing it, we can reduce the number of records and improve the processing. Another type of person to look out for, or subscribers, could be sort of tourists, or let's say flyby persons. That could be subscribers that have very, very few events that might be scattered throughout the time period you're looking at. So for example, in this area, there might be a person that have 3 different events through an entire month in different locations. So it's hard, obviously, it would be very tricky whether this person or the subscriber would live in this area. So we can remove them and assume that they are also flyby persons, people that might just visit it for a specific day or just passed by in a car, for example. The last step in terms of filtering is also looking at other tourist filtering. And this could be subscribers that have events during a limited time period of the month. So the example here is that here we have a subscriber that is only active in 3 days in this time period. It has many events, and but it's not there the whole time period. So it could likely be a tourist. And by removing them, then we would get a lot more accurate results than later on the home location. So once these are a few different types of filters that the notebook do. There might be, if you have real data, there might be other filterings that need to be done. These are the ones that are currently included in the notebooks. And you can set them in with different types of parameters of what you suspect in terms of the location you're looking at. And then after that, the pre-processed data is saved and it's moved on to the next step. So now I will give back the floor to Esperanza for the next step in this process.
Thank you, Frederick. So after the data has been checked with regards to or pre-processed with regards to the different elements that Frederick mentioned, the next step is to see the quality of the data. So like any other official statistics, we need to ensure quality of the data that we will be analyzing. So this notebook, which we call quality assurance, will provide some of the elements that we need to look at. And the idea here is to look at the input data to make sure that the output data will be as of high quality. And so even though, for example, there has been some pre-processing that was discussed already by Frederick, we may still see some strange results when we run the notebooks that relate to checking the quality. And so what are these quality assurance? So we also classify this quality assurance parameters into a certain set of indicators with regards to whether you can accept them or not. There are results that they are basically a characteristic of the data, but some of the elements that you need to pay attention to are those that will say, okay, it's important you check them, or is it critical to check them? And there's also the results from these steps that will indicate whether the step will allow you to pass the step and perform the next methods, or you can accept them with some reservations. And so when you analyze the data, you have to take into account these reservations. There's also an indicator whether your results failed. So the quality assurance step will tell you that your results is not acceptable. And so it means you have to go back to the operator and see how you can correct the data or get explanations as to those strange results. So in this Jupyter Notebook, we are looking at 7 quality assurance indicators. One of them is on the subscriber statistics. So this is just a description of how many subscribers there are, and I'll go through all the details of this later on. We look at percentage of null values, consistency with regards to the subscribers and unique cell locations. We also look at whether all locations are within the boundaries of the country. And we also look at, for example, the distribution of subscribers with regards to the active days, or the distribution of the subscribers' activity during the day. So these are the 7 parameters that we will be looking at. So as I mentioned, the generation of user subscriber statistics is just a description of your data set. So to see whether, for example, the data that you have between the period that you are looking at are consistent with regards to the number of records. So it has to be able to show consistent amount of records so that when you aggregate them, you will get consistent results. So you will see so in all these slides, we are showing pieces of codes, and these are just extracts from the Jupyter Notebooks. And at the bottom, the pink part, you will see the output, for example, of that particular quality assurance indicator. We also look at the data set with regards to presence of null values. So the columns, we have 7 columns here. If you can see, doesn't show any null value. So the table, so this piece of code will generate a table that will show you the percentage of null values in your data set. There's also the text in blue, and this is what I mentioned earlier, the output. When you run this piece of code, there will be an indication whether your step passed or failed. So in this case, we have a parameter that shows you that the step passed because there are no missing values. We also can accept it if there's less than 5% of missing value. So it's up to you to define this percentage of missing values. And that will be the passing point with regards to, or the acceptance point that you will be discussing with your stakeholders. There's also this check with regards to number of subscribers per day. So there are 2 data sets that we are looking at in this mobile phone data. One is the call data record that contains basically the events when you make your calls or use the internet or send SMS, and also the IPDR. So the IPDR is basically the data set that contains the internet events. So what we would like to see is that these 2 data sets are showing the daily subscriber consistency. And so, for example, in this chart, you will see that the green and the red lines, they should normally be coinciding. And so when you see dips, then you will have to see why the number of subscribers are differentiating for those particular period. There's also from the code, so when you run it, you will get a user consistency report. So it will give you also an explanation on the irregularities that you will see visually, and it will be supported by this note at the bottom of, as you can see from the bottom of your screen. And it will show you also some suggestions with regards to, whether there's a data processing error or whether there's a data loss that could explain these inconsistencies. The number of unique cell locations is another QA, quality assurance parameter that we are looking at. We have to make sure that the cell locations are consistent for both IPDRs and CDRs. So if there's any diversion, then you will have to go back again to your data set and find out why there are discrepancies or irregularities. And this, again, the same piece of information with regards to the report. In this case, for example, it shows it failed. So you have an action plan to find out why there's instability in your data set. There's to check any issues related to your cell tower data set. Whether there's a problem with the data aggregation. And then it's important that you collaborate with the network operations team to rectify any of the issues and ensure that the data are accurate and stable with regards to the cell counts. The next QA indicator is to examine whether the location of your cell towers are within your country boundaries. So this is an example, for example, of the country cell towers. So this is based on the synthetic data that Frederick mentioned earlier. So, for example, this red dot here, you can see that it's not necessarily within the mainland. And so, for example, you may want to see whether all these dots that you have are within your geographic boundaries. In some cases, and this was our experience, when we were testing some of our synthetic data, we can even see cell towers going far beyond the geographic location that you're looking at. And that is something that it's important to check. So the subscribers activity in the 24 hours. So this is, if you can see the chart, this is again referring to the call data records database and the IPDR. So for the data events, so for the internet events, and the bars shows you the hours of the day. So it looks at 24 hours. And this chart shows, for example, that at midnight until dawn, so for example, early morning, the activities with regards to those for calls or internet are basically low, and it starts to peak at the time when a subscriber or a person leaves her or his home location and until the time when the person returns home. So the idea here is that the charts should look like an elephant shape. And so the codes, the Jupyter Notebooks, will run the codes and will give you an output that will generate a report to indicate whether your data set follows an elephant shape or not. And so, for example, this one, it failed, and it says that the CDR and the IPDR is not following an elephant shape, and that there needs to be an investigations on the reasons why there's a deviation from the distribution that we would expect. So there are different criterias with regards to checking anomalies and patterns. It can be, you can see flat pattern, for example. You can have spikes or peaks, and you can have an inverse pattern where the non-working hours are showing more activities than those of the sleeping hours. So those are patterns of the data that you have to check. So this is the shape, the elephant shape that I mentioned earlier. So for example, that it will show you an elephant shape, so that this is a normal pattern that we would expect that the activities of that with regards to mobile phone data. So just to summarize, there are 7 key quality checks that you need to perform to make sure that your data are good for further analysis. And until you pass all these key indicators of quality assurance, you should keep going back to your operators and have your stakeholders discussion to ensure that you will pass all these stages. But until then, you cannot go to the next step. So these are the 7 key indicators that you need to pay attention to with regards to ensuring quality of your data for your further analysis. And with that, I think this is the end of my presentation, and passing to Frederick for the next notebook.
Thank you again, Esperanza. So moving towards the defining the home location, assuming that you have checked that the data is looks good, you can then start sort of moving to actually using this data. What we need to remember of the CDR data is that we're actually looking at, let's say, dots at different locations in a way. It's different patterns of where people are moving. But the home location is really in a way also where the magic is starting to happen in terms of trying to identify and linking a person or linking a subscriber to a specific person or the home sort of. This is the link from the mobile phone data to be able to do statistics and then allow it to map the subscriber data with different reference data on population, geodata, and so on as well. It's a crucial step for information society, but also many other mobile phone data use cases. And it's really to try to, based on all the dots that we're seeing, what is the most probable location that could be the subscriber's home? It's not necessarily that easy. There's other methods as well of looking at different anchors, looking also where the person might work, and other common locations that the person might go to. But the home is the most important. There are many ways to try to identify this. It's not necessarily it's not always easy as well, and depending on the method you use, you can get different results as well. Simple ones can be just looking at the amount of activity, where the most calls, texts, or data events were recorded. Now, this could then lead to that maybe your home location would actually be your office, who knows, or someone else. You can also look at the number of active days where there was most recorded. You can start looking into the time of these events as well. Let's say where the events were happening during the evening or during the morning, for example. There's also other versions in terms of looking at different kind of spatial aggregation, of looking at events within a specific area, and so on as well, or a combination of all these. So there's many different ways to define or try to identify the home based on the mobile phone data. One thing, just this is an old report from many years ago, but it shows it quite clear. It shows the different hotspots of mobile phone data usage in France. And looking at the validation data set as well, there's to the left, there's a big circle around Paris, around here, which is where a lot of people live, and also in the north and in different cities. And then when you go towards August, then a lot of people obviously go to the coast. So there's a lot more hotspots along the coast, which is not necessarily where the people live. So the time period you're looking at can also be a crucial factor when you're trying to identify the home location. The notebooks use a home location that was, I think, also used in Brazil. It's more of a time-constrained sort of anchoring model that gives more importance to the time of the day that are more likely to reflect where the person when a person is at home. So it starts with specifically mainly looking at the weekdays, Monday to Thursday, not necessarily Monday to Friday, which it says here, where person is home. Fridays and Saturday nights and Sundays might be slightly different if you go away. And then it looks at the overnight activities, and then the morning and evening, and then lastly, it's the daytime. So it's sort of a prioritization rule that applies in terms of try to identify the home based on the patterns that you see in the data itself. So the first thing that the notebooks do is that it creates two different types of summaries. One is a user summary, which is used later for the indicator creation, to looking at the unique days, the cell location, and the principal technology used, and if the person have accessed the internet using the data events, for example, or just doing regular calls. There's also the cell summary, which looks at try to classify each activity or each event according to different time windows. So in the notebook, we have 4 different time windows. We have the night, we have the morning, and actually, sorry, it shouldn't be the night, it should be the evening, and then daytime. And this is these prioritization. So the night is sort of the strongest clue that you will be at home. And then the morning and the evening are also more cases where you would most likely be at home. And during the day, we really don't know exactly where you might be, quite at work or somewhere else. So this summary is really the basis for the home location. Based on that, we try to look at, for each day and time, try to calculate the number of events or the number of records that happen in each cell time, to try to identify the most used cell for the specific day and the subscriber. So, for example, here, the subscriber number 7 for the first day, it was mainly connected to cell tower ID 2119 in the night and also in the evening, while the morning and the daytime was a different cell ID. So this is the first step to looking at this for a specific day. The third step is to count the number of days each of these locations or cell IDs actually, let's say, win on most days. So if we're looking at a time period here, we can see that during the weekdays, the 2119 beats 528 by 84 during the night, and it also beats it in the morning as well. So in this case, it seems likely that this cell ID is where this the subscriber actually lives. So that's the first of the summary. The decision-making logic is then what the actually what I already mentioned, but what we're getting into now is to looking at the prioritization order. So the weekday, the night evidence would be the strongest signal of the home, and then looking at the morning and the evening, and so on as well. Now, in some cases, if you have very low activity users, you might get into the weekend as well, or simply remove these or treat them as unclassified if the subscriber, if it's too hard to identify where the subscriber actually might live. So just taking a few examples, here we have the same one again. I can see that cell 2119 has most events during the night, during the weekdays, and also during the morning, evening. But it's sort of clearly, let's say, the winner, and assumed that this cell, this subscriber, then its home is close to cell 2119. If you're looking at more trickier options, another option is this other has cell under 411 and 522. During the night, you have the same amount of times when these cells were the most used. But if you're looking at the morning and the evening, it's clearer a little bit for the cell 411. So in this case, we would classify 411 as a tiebreaker between these two, and we would classify 411 as the highest probability that this is the person's home. Now, go falling down the same. If you have same the tiebreaker, then you're looking at during the daytime, and in this case, it's cell 100 and 305 for the subscriber that would be the winner. In some cases, it might be very, very tricky. And here again, you can try to look at, as I mentioned, either remove them. You can't actually see where this person might live, or you choose one of the different options that are the highest probability. So in this case, a very low user during the weekdays, but during the night, it's tied between 777 and 888 cell ID. In the morning and evening, it's slightly more for 777. So the final tiebreaker here would give the option to classify cell 777 to be the person's home. It could obviously also be that these cell locations are very, very near each other. So once you aggregate the data, it might not, it might be in the same area, but we don't know that necessarily from this. So just a short summary is to summarize the data, set these anchor points. You can classify the time of the different anchor times in the notebook itself. It's usually, now I think it's by default set from midnight to 5 in the morning, and then 6 to 9, and then also in the evening. But these are customizable directly in the notebooks as well. Also preferring which days, weekdays. Now it's set to use in Monday to Thursday as a priority, and then go into the weekend as well. Here's an example is using the Rwanda of where the location of these 10,000 subscribers that we generated would be. Most of them were in the city of Kigali, the capital. But looking at the statistics, which is also appearing directly in the notebooks, you can start seeing what was the at which stage was the person decided where the home location was. So the weekday night confirmed is really more than or half of the cases, which is where there was a clear winner during the night, but this was also supported by the clear winner of the cell ID also during the night and during the morning and the evening as well. So in most of those cases, that it's pretty clear which is the cell that you would be considered a home. It's only a few cases where it's very tricky. So thank you for that. I will give back the floor again to Esperanza for the next on the indicator calculation.
Thank you, Frederick. So just to recap, so the first notebook that we showed was to check the quality of the data with regards to specific characters, for example. Then we pre-process the data to eliminate them. And then Frederick showed you, and then I showed you the quality assurance to make sure that everything is good with the data. And then Frederick assigned the home location in his last presentation. And so now what I'm going to show you is how do you do the calculation of the indicator after you assign the home location. So this slides will run you through the.
You're muted, Esperanza.
You're muted, yeah.
I'm sorry for that. I don't know how much you got from what I said, but I was just trying to recap the previous slides. So after you went through checking the quality and the different details that we showed you earlier, assigning the home location, the next step is to calculate the indicator 1781. So there's a lot more applications of mobile phone data that you can do after you clean the data and assign the home location. And here we are just showing you one of them, which is the calculation of indicator 1781. So this is just again a recall on what is 1781. So we will go through all these processes, and this is the output that we would like to achieve at the end of our analysis. So what are the steps in calculating this indicator? So first, we need to see the scope of aggregation. So if your policymakers or if your national statistical offices are interested in looking at more the district level data, you have to have the data where you will be able to analyze that level of aggregation of data. You need, of course, all the data with regards to the customer relation. So if you would like to get more information with regards to gender, age, then you need to also look at that data and link that data with the anchoring data that came from the process that Frederick showed you earlier. And then you can calculate the indicator, which is based on the data that came from that last step. And then you have to validate the data against the survey results. So if you have a household survey, then that's very good. But you can also validate it against other administrative data to make sure that they all make sense. And calculating this indicator requires that you look at the sum of the different events that are in your data set. So for example, you need to sum the subscriptions that are only generating voice events. You also have to sum those that are generating data only events and subscriptions that are generating both events. And what we are interested is basically the number of people that are using the internet. And so for us, the closest proxy to that is the number of subscriptions that generated data only events or both data and voice events. So you need to sum these two, or you need to aggregate these two data sets. And then you have to also know, for example, where those subscriptions are. So it's important to know the type of network that the subscribers connect to, and that's how you can disaggregate them by 2G, 3G, and 4G network. So as soon as you have those aggregations and information on the networks, you will be able to calculate your indicator 1781. And here, like what I mentioned earlier, what we look at is the highest technology that they connect to, and use that as your um, assigned technology for that particular subscriber. And after you get all those information, you aggregate them, and then you divide them by the total population of that particular geographic location that you're looking at. So for example, if you would like to know how much of the population is connecting or using 3G connections, then you will select those subscriptions that generated 3G out of that particular geographic location and divide that by the total home count of that particular area. And so this is just an example of the table that of a table that it was generated to show, for example, this was the data that we were looking at, an example in when we were in Maldives. And so this is the different districts that were available at that time. And the table will show you, for example, okay, these are the total home count with regards to those that generated internet traffic, or only 2G networks or only in 3G networks. So it will provide you the disaggregation by type of network, and it will also show you those subscriptions that have never generated any data traffic. And in terms of visualizing the results, so internet use can be visualized according to your geographic location. So for example, here, the example from Rwanda, where the map shows you the concentration of internet users. And here, what we would like to show is that these are still based on your data set, on the subscriber data set, because the next presentation will show you some of the adjustments that you need to perform to be able to deduce or to conclude on your internet user data set. So this is based on subscriber data. And so, for example, in this municipality of Rohangu, where the data shows you that there are internet users 50%, and when you disaggregate them by type of technology, you will be able to see which is the dominant technology that is being used by the subscribers. So in this case, this is a 4G technology. So you can have all those details when you have the necessary data, both geographically and also by technology. There's also a possibility to look at the data by municipality, for example, and the type or split by technology and no internet connectivity. So, for example, here the circles will show you, the red part of the circles will show you that this particular municipality has no internet, and also the green will show you that they are mostly using 4G or in some cases 5G. There's also a possibility to show rural and urban, because this is an SDG indicator, and it's important that we disaggregate that by the type of zones that are in the country, and that is another reference data that you need to have to be able to disaggregate your results according to these breakdowns. It's also possible to disaggregate by age and gender, and that's why you need to link them to a third data set I mentioned earlier, which is called CRM, the Customer Relation Management Database. And this is captured whenever you get your SIM card and the profiles of the subscriptions. So with that information, you will be able to see how much of the data relates to a male or female, and you can break it down and show even with age and gender. So I think that's all from my side. There's a lot of information coming from us today, but we will be, I think, going to present to you in the next occasion a real experience and how these notebooks are used. But there's another set of notebooks that Frederick will be showing to you, because I'm sure you are asking the question that this is just based on the subscription. So what happens to the rest of the population? And so Frederick will be showing that to you. Over to you, Frederick.
Thank you so much, Esperanza. And I see that we don't have so much time left. So I'll try to be quite quick with the last presentation as well. I also just want to mention that the figures that are shown is, of course, it's synthetic data we generated for Rwanda. It's not necessarily, in this case, real figures. So just to be aware of that. There's also a lot more things that can be done with the data as well, looking at the maximum technology or the most frequently used technology in different areas, or the subscriber activity as well. So there's a lot more that the data can be used. So I just wanted to address and showcase a little bit on kind of more on the research side, that we're working also with some of the countries just to test different methods. Obviously, there's different estimations, and if you would see this, then you might start asking some questions. If there's more people using the internet that actually exist in the population. So there are different biases, and this is also questions we usually get on mobile phone data. There could be that you have multiple SIM cards in one phone. For example, that could be an overrepresentation of the data itself, whether obviously if you're actually using them on a regular basis. It could be that you're having two SIM cards and one you're only using maybe in different areas and so on as well, or different countries. But this is one possible overrepresentation of duplicates. Another one is if you have multiple phones per person with either one or different subscriptions. One, basically, that you would be switching phones and having this one SIM card, switching it between multiple phones. Or if you are registered as the owner of other person's phones, for example, if there's an adult with the children, which is not necessarily a duplicate, but it could look like a duplicate, or that you have multiple subscriptions in, let's say, a CRM database or from the mobile operator. But you might want to include all of these. There might be also different market shares depending on how many and which mobile operators you're working with, whether all of are providing data or only some of them, and whether these are representative of the population as well. So there's a lot of different factors that are still sort of researched and see how to best deal with that. So I'm just going to showcase just a few. Two of them refers to try to deduplicate and trying to remove this at a subscriber level. And then one is, the last one is focusing more on kind of adjusting the final results and reweighting it to try to better fit with the overall, let's say, internet use in a country. So looking at deduplication, one example is, let's say, using privacy enhancing technologies, for example, where you have privacy enhancing technologies that can sort of generate the where the data is fed, and this is sort of a secure environment where the data can be processed, and the subscriber data, anonymized data, could actually be compared, for example. So one just example of how it could be used for mobile phone data, let's say you have 3 different operators that put the data encrypted and hashed into secure multi-party computation, where these working on different types of nodes, and you can do this removal, for example, keeping the subscriber with the most data points or the best, let's say, quality flag, or if you do a similarity score based on, and then after that you combine it and have a smaller data set that you then can then aggregate, for example, and then send it to the regulator or national statistics offices. Another part that could be part of such comparison is a similarity score, that if you're looking at where the subscribers are moving, going to, where their home location is. If they have a lot of similarities over a long period of time, then maybe it's possible to try to identify them as they could be the same person, or whether there's two different persons. So here is an example using, let's say, the house door distance. I'll not go into that methodology, but just showcasing that this is an example from Mongolia of one trajectory of subscriber 1 and trajectory of number subject 2. They're all their movements in one day. And we can clearly see that they're probably not the same person. It's two different trajectories. It would be difficult to move them as well. So the house door difference is quite high. Now, another example, if we're looking at these two trajectories, could these be the same individual, perhaps, if these are 2 different days, let's say, with 2 different subscribers? Maybe it's quite similar. We might need to see this pattern a lot longer, over a long period of time, to try to then identify whether these are two different subscribers or not. Now, the other part is, let's say, post-adjustment and reweighting. So here are also different ways of actually also using the mobile phone data itself, or using other survey data to try to complement it, to try to reweight the final results for the general population. So, for example, one thing that we need to consider is looking at the percent of children that are normally not allowed to have subscriptions by themselves and not being adult in many countries. So they might need to be removed. There's also, depending on the country context, could be a different share. In some countries, a sizable share. In other countries, a very small share of people that actually don't have a mobile phone as well, that are not part of the information that is collected from in the MPD. And also looking at the number of SIM cards per user, or looking at the duplication again. And then in some cases, as an additional factor that we can take into account, that is very hard, is, of course, if there are people that are using the internet, but they don't necessarily have a mobile phone. This one could be set to 0, or we can have a small percentage there as well. So this is one example of just how such post-adjustment could potentially be done. If we're looking at, in this case, we have 2 different operators. We have an area with 100,000 population. We're assuming children are 20%, so we have 80,000 as the adult population. 15% do not have a mobile phone, so the mobile reachable population is down to down further less. And then working with the 2 operators and their market shares, the calculated internet use from the mobile phone data, and the SIM cards per users. Now, some of these can also be, as I said, collected in household surveys, if you have indicators on the mobile phone ownership, for example, or number of SIMs per user. And then you would get sort of a final estimate of internet use for the country of all combined. So this is just another example of the data that Esperanza showed when we would run this, let's say, in the notebooks for Rwanda. Now the figures are much less as well, where we can looking at the adult population and follow these steps. Now this also, the final step is also compare it against the survey data as well. These were two comparisons that was done, I think, directly from the mobile phone data against surveys in Brazil and Indonesia for a few years ago. So just, I think that's it. There's a lot more information actually on our big data website if you want to find more information. This is also where we are adding new information as well. We add in some synthetic data and other reports and methodologies as well. So it's go in and check it out. So thank you so much. And please let us know if you have any questions. We don't have so much time, but I hope so.
Well, thank you both for this excellent presentation. We don't have yet any questions in the chat. Please, if you guys want to question anything for the presenters, Please write the question down at the chat so I can aggregate them and ask. I myself have one question that I've prepared for you. I'm a geographer by formation, so we deal with a lot of modifier area unit problem. This is very important in official statistics because it's when you balance the trade-off between when you disaggregate some statistics for level administrative level units, but sometimes it's more important to disseminate these statistics in regular grid like H3 hexagonal grid that we do a lot in statistics and transportation. So my question is how to balance these trade-offs and how regarding statistical reliability and the other questions of privacy, how to balance this with mobile phone data. Thank you.
Thank you so much. Maybe I can try, and then Frederick can also add to that. In the notebooks, and I think this is also in the work of the task team, what we included in all the methodologies is you have to define the level of or the number of subscribers in that particular geographic locations that you can accept. It varies country by country. In some countries, it's like maybe 5 subscribers to make sure, or 15 subscribers to make sure that you cannot trace it back to that particular subscriber. When we were in Maldives, we were talking to a geographic location where only maybe 10 people stays during the night because it's a very small area. So you cannot really show the data for that particular location, not at all, because that will jeopardize the privacy of these subscribers. So that's one of the examples that we have. Frederick?
Yeah, I can also just say I know, for example, in Europe, there's some telecom operators that are starting and also sort of selling products based on the mobile phone data, and they do the same thing. I think in Sweden, they were also using a minimum, I think they had minimum 10 people actually looking at the transport, for example, which is quite small, I would say, 10 people. But yeah, this is definitely one thing.
Thank you. I have Daniel here. He's a master student and have a degree in telecommunication. I believe the question is more related to which research areas are open to work on a state-of-the-art topics or some kind of methodology evaluation. I believe is these research areas by formation, by academic formation, I believe.
Yeah, I mean, if we stay in the topic of mobile phone data and how it can be used for official statistics, there are still many areas that needs research, and even from our area on information society, we're just looking at one indicator. We are not even talking about other indicators with regards to, for example, coverage. We have that also in our methodology. We have mobile phone coverage. We also have, in household surveys, we know how many people are using the internet to get communication or information from government agencies. Can we also get this type of information from mobile phone data? So there's a lot of areas that we can still dig in if we have the time and the resources, and if we have the data, of course, because mobile phone operators have a lot of data. We are only looking at the tower level data. They have data on, what are the information a subscriber, for example, in terms of IoT services. So they can also see whether you use it in WhatsApp or whether you use Facebook. So you can have all these parameters if you have access to the data. But that is another discussion, I would say.
Yeah, can I compliment as well? I think that actually I presented the last presentation as research areas as well. And I think on this case, as deduplication, let's say, which is also quite tricky. It depends on the information that operators have, and this can also vary across different countries. So this is also an area of very much interest as well, of exactly how to do that and what to do with that is, let's say, computationally not too heavy in this case.
Yeah.
For example, if you're comparing trajectories, you cannot necessarily compare a trajectory with 100 million subscribers. It's impossible. So where do you draw the line? How do you identify potential candidates in this case as well, and make it possible?
Yeah, I believe we are at the time that we establish. We're going to have the workshop in September. Yeah.
Yes,
Uh,
yes.
so I invite everybody here to attend this workshop, and of course, if I believe.
Christoph.
Yeah, Christoph, yeah. Can you say a word on the relationship with operators? That's important to topic. How do they welcome an NSO? Are they contributing to the results analysis? How are the relationship between NSOs and the MNOs?
Yes. So thank you, Christoph, for this question. This is an area of work that we are working both at the ITU as an organization and also through our joint collaborations with experts working on this data, including our collaboration with the ITU and the World Bank. And here the idea is to put all stakeholders together around the table, define the use case, and involve as early as possible the operators, the National Statistics Office, regulators. And the usual path is that the National Statistics Office works with the regulator, and then it's the regulator that connects to their mobile operators because they have their license obligations to the regulator. So this important component of collaboration and cooperation needs to be there so that data access will happen. Otherwise, if an NSO goes directly to the operator can say, oh, we don't have an obligation to answer to you unless they have this corporate responsibility to return back to the public what the public is giving them, and so they are able to provide the data. But otherwise, this collaboration has to take place by making sure that everyone talks and every role is defined from the start.
We also have Vicente that is asking how to stay in touch with the to participate these events. We all these events, webinars and the workshops that the regional hub the UN regional hub in Brazil. We have the direct in our website, so we advertise these events ahead in our website. So stay in touch with the information, and then we can register. You can register to participate in these webinars and the other types of event. Um, Oh, I believe if we don't have any more question,
Can I just say
uh,
something, Tiago,
yes,
just
please.
to flag the
Yeah,
workshop because you mentioned about the workshop in September. So maybe you're
yeah.
wondering, we only showed you slides, and this is really the purpose of this today's session, because in September we're going on hands-on workshop. So if you want to experience running the Jupyter Notebooks, register in those two workshops, I think, Maria Luisa. So register in those two workshops because the space will be limited because we can only cater around, I think, 25 people per session. And the idea is really for you to run the notebook. It's an immersion workshop. And so you don't need to be a data scientist. We will just tell you which button to hit to experience running the notebook. So we hope to see you in that workshop. Thank you. Thank you, Tiago and Maria Luisa. And thank you to all for listening today.
Thank you, everybody, and see you next time. Thank you. Bye.
Thank you so much.
Thank you.